Hello everybody, it's Mr. Woodward here. In this lecture we're going to talk about friction, specifically two types, static and kinetic friction. So let's take a look. Over here, friction is the force that resists slipping and sliding. When two objects are in contact, the molecules on their surfaces press against each other and provide a level of stickiness, acting like Velcro. Suppose you want to prevent two objects from slipping or sliding. In order to do this, you might add grip to the surfaces or press them together with more force. This is because the friction between two surfaces is determined by, number one, the roughness of the surfaces, and two, the normal force between the surfaces, right? So friction between two pieces of sandpaper is going to be greater than friction between two pieces of ice because of, number one, the roughness of the surfaces, right? But if you take those two pieces of sandpaper and you press them together with greater force, then you can actually increase the friction because you're increasing, number two, right, the normal force between the surfaces. So it's not just the roughness of the surface by itself, but it's also how much those surfaces are being pressed against each other. Let's keep going over here. The grip between two surfaces is described by their coefficient of friction. This is the Greek letter mu, a number usually less than 1. The higher the mu value, the rougher the interaction between their surfaces. For example, rubber on asphalt, right? Rubber on asphalt, think about a car tire, might have a frictional coefficient of 0.95, while ice on ice might have a frictional coefficient of 0.01, which would be very small. You can calculate the force of friction between two surfaces using the following equation. And here's the general form of the friction equation. The force of friction between two surfaces is equal to mu, which is the, remember mu, the coefficient of friction, mu times the normal force. I meant to erase that. Times the normal force between those two surfaces. All right, so we have the general form of the equation for friction, but now let's zoom in and let's consider two different types of friction. There's actually a third type of friction called rolling friction, which I'm not covering in this lecture, but we'll take a look here at static and kinetic friction. Friction comes in two forms, static and kinetic. Static friction prevents objects from slipping. While walking, you can thank static friction if your shoe successfully grips the floor. Thank you, static friction. If you slip, however, and you start sliding, kinetic friction takes over and eventually brings you to a stop. For example, while moving a refrigerator, you must first overcome the force of static friction to get it to move. Once it's moving, you must overcome the force of kinetic friction to keep it moving, right? So static friction is to initially get it to move. Kinetic friction is to keep it moving. Looking over here, static friction is a variable value and can increase up to a certain point, the point of slipping. Once static friction is overcome, kinetic friction is the next and final line of defense. Interestingly, the force required to initially slip is greater than the force required to keep sliding. Therefore, a surface's coefficient of static friction, called mu sub s, is greater than its coefficient of kinetic friction, called mu sub k. You can calculate the forces of static and kinetic friction using the following equations. Okay, so over here, we've got the static friction equation, and it's got mu sub s, which is describing the coefficient of static friction, the coefficient of this like gripping friction. But then also notice that it has this less than or equal to symbol, which means that static friction is not just one value. It's actually a range of values that is up to a point of slipping. That's why we have this less than or equal to symbol. But over on this side, for kinetic friction, I'm actually going to change colors to exaggerate the fact that they're different. Kinetic friction has the coefficient of kinetic friction, and then it's got an equal sign, which is indicating that kinetic friction is one value. So we're going to look at an example that's going to really differentiate static friction versus kinetic friction. And I'm going to do that in the next lecture.